Welcome back, everybody. Welcome back to the channel. So today we're going to be talking about how to parse for each statements. So we're going to continue where we left off. So if we go here, first thing you guys are going to want to do is create your is function. And the keyword in question is for each. So you guys can see what that is. Once we check to see if the current token is equal to for each, of course, as usual, we prevent the user from having any access declarations. And then of course we return true because we successfully processed a for each statement. After that, we create our for each function, and in there we have a AST for each statement. Now, the concept of for each is you pretty much want the user to be able to iterate over any array without really having to write too much boilerplate code. So if we have like an int array or something, and let's call it numbers, and let's see, so I'm going to remove this here. So if we have like our numbers array or our numbers value, so if we say for each, and we can say number or num, and then I think I say in numbers. So we want to for each number inside of this numbers array. And basically what we want to allow the user to do is like we can do one of two things. We can either allow the user to just say, all right, I want to, create this local variable, and I want to use that local variable inside of this for each. Or we can like force the user to, denote what the type of the local variable is, which is pretty much unnecessary. You don't really have to do that. So yeah, that's completely unnecessary. So if the user just wants to say, for num in numbers, that's totally fine. I actually like this format a lot better. It's a lot cleaner. But yeah, so let's actually see how we do that. So first thing we need to check is our left paren, pretty standard. And then this is where we check to see if we can support, just the num value or the num and the expression. So if we have, the next token afterwards, like we're assuming that the token after this parentheses is going to be an identifier. So we're just going to not even check that. We're just going to skip over and check the token after the expected identifier and see if that's equal to this. If so, then we want to parse a utype arg. You guys know what that is. I don't even think I have to go over it. So just call this function. And then after that, so like if it turns out to not have this colon here after the identifier, and we just have like num in this example, then what we want to do is we just want to create a AST called AST utype arg. So you still want to create this AST, which is the same type, and you want to just expect an identifier, and that's it. So that's how we support that. And then we basically expect in, and we parse our expression. So, it doesn't just have to be a variable. It can be whatever the user wants to put here. So we parse our expression, we parse or we expect the closing parentheses, so the right parentheses, and then we just parse a block, and that's it. So let's see how this code actually looks. So I remember, where did I last put the AST2 string? And let's see what this actually outputs. So I'm actually planning on doing a video, guys, about system requirements. The system requirements for building this programming language has increased substantially, and it's kind of a bit of bad news for some of you guys if you're following the series. So I will make a video about that after we finish parsing statements. But yeah, there's been some changes to like some of the things that I use for building this programming language, as well as, like I said, system requirements. So I'll make a video about that later. We don't have to really worry about it now, but let's just kind of see how for eaches look. So we have our for each statements. We don't need these characters, so you can not have them if you don't want to. We have our utype arg. So you can see here we have our just num, right? That's our num variable. So we need to create this variable inside of our, on the backend side, we need to actually create this. And if there was a num variable like up here, like if we had like, I don't know, num is equal to 100, then of course we will complain about this value, num not being there, because the assumption is that they're creating a variable, they're not like reusing a variable. Just personal preference. I would not recommend you on the back end, like, okay, if num already exists, then use that, because that's just not, you don't know what they're using this variable for. So up here, they could have it in a for loop, it could be, used in some switch statement or some condition. So you always want to create a fresh variable. So, um, after that, we have our expression. So that's going to be the bulk of this, and it's just numbers. So it's just a dot notation call expression of a U type of numbers, and that's it. And then we have our block, and that's pretty much it. Um, and you can kind of see down here some of the code for each. Not really going to go into it. It's actually kind of interesting though, because once we start getting into building out the actual code for our virtual machine, like it's interesting to see like, oh, it's well, apparently for each statements are actually a lot more efficient than for loops because they somehow generate less code. So it's going to be a lot of pretty cool stuff we're going to be seeing as the series goes on. But yeah, so that's going to be it for today, guys. As usual, if you guys have any questions, definitely write them in the comment section below. And of course, if you guys want to help support the channel, definitely head over to my GitHub repository at androidevcity/sharp. And when you do, definitely watch, star, and fork this repository. That's going to give this language a lot more visibility and let other developers know this language exists. Also, if you're curious about maybe things that I do on a daily basis, check out the remastered branch. And in there, you can kind of look at my commits. For the most part, I write pretty wordy commits, so you can kind of get a gist of what I'm doing without really having to like know exactly what I'm doing by looking through the code. So yeah, you can check that out. Pretty cool stuff that I've been putting, tons of bug fixes and other things. Also, if you're curious about maybe seeing some of the things that I've done to the past, or maybe stuff that I'm looking to add into the future in this YouTube series with the language, definitely check out the docs folder. You're going to find basically what you need. You can check out the changeless file. That's going to be pretty much everything I've already done to the language, like old stuff. And then you can check out the roadmap file, which is updated very frequently. You can see like the difference in update time is pretty drastic. And that's pretty much going to contain not only stuff that I've already finished in the language, but also stuff that I'm looking to add into the future. So definitely would recommend checking out this file. That's going to give you a lot of insight into the language. And yeah, so that's going to be it for today, guys. As usual, if you guys are new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.